In our final video, what we're going to do is we are going to go through and given the graph of the parabola, let's see if we can find the standard form. Okay, so we're basically going to take this graph and write it like this. Okay, and actually it's not too bad to do this. First thing we do, let's identify HK, and then let's also figure out a point, okay, that exists on the parabola. So let's find an X and a Y. Okay, so it's pretty clear that right here we have that H is 2 and K is -2. Okay, so it's going to be 2 and -2. And then another point that exists on the parabola is right here at point 0.06. Let's now plug all those back into the form and let's try to solve for A. Okay, now remember, Y is the same thing as f at x. Okay, and so that's going to give us 6 for f of x is going to be equal to A, which we don't know, 0, which is x, minus h, which is 2, and then minus 2. And there's a square here. All right. Now, our goal is to solve for A. Okay. Then what we could do is we can get to the standard form. So to do that, let's add 2 to both sides. And if we do that, we get 8 equals A, quantity, -2 squared. And then if we evaluate that, 8 is going to be equal to 4A, or 2 is equal to A. And so the function, which I'm going to call f of x, is going to be equal to 2 quantity x minus h, all right, which is going to be 2, and then plus k. All right, so looking at our formula, we have plus k, and k was -2, so I'm just going to say -2. All right, now let's go through and just for the sake of checking this first one, let's see if it matches up to this by plotting it in Desmos. Okay, so we have y equals 2 quantity x minus 2 squared minus 2. All right. Remember, we had the points -2, comma, or 2 comma -2 on the graph. All right. And remember, that was our vertex, which it is. And then we also had the intercept of 0, 6 that should be on the graph, which it exactly is. All right. So that's a way that you can check your answer just to make sure that once you get this standard form, that it makes sense. Right. So a secondary example, we have this is a point and this is our vertex. Okay. And so once again, we identify h as -1, k as -4, x as -3, and y as 0. Remember, y is the same thing as f of x. Our standard form, f of x equals a quantity x minus h squared plus k. And so let's plug everything back into that formula. So once again, we can solve for a. Okay, and so that's going to give us 0 is going to be equal to a times x minus h. So that's going to be -3 minus a -1 squared. Okay, so remember x minus h squared, and then plus k plus a -4. Okay. Now what I'm going to do is I'm going to add 4 to both sides. So that's 4 is equal to a times -2 squared. That just becomes 4 equals 4a, and so 1 is going to be equal to a. All right, so that's good. And so that means that our function f of x is going to be 1 quantity x minus h, which we said was -1, so minus a -1 square, and then minus 4. Or if we were to put this into a little bit simpler form, f of x is going to be equal to x plus 1 square minus 4. And I think we can clearly see that the vertex is at -1, 4 just by looking at this. And then if I plug 0 back in, okay, 0 would be the point 0, -3, all right, for the intercept, which it looks like is right about here. Okay, so at least it looks like it makes sense, but of course, we can always trust Desmos. All right, so let's go ahead and plot. So that's going to be x plus 4, or x, excuse me, Let me go back. It was x plus 1 minus 4. So that's going to be x plus 1 square minus 4. All right. Remember, our vertex point was -1, comma 4, and I believe -4, excuse me. And I believe the point on the graph that we had was -3, 0. All right, there we go. And so this graph looks precisely, well, really close to the graph that we were given initially. Okay, so we can see that this parabola and this parabola look the same. So that's how we can go through and we can try to figure out the equation in standard form if given just maybe the vertex, which we can usually find easily, and some point that exists on the parabola. Okay, and that's going to do it for everything in quadratics. Okay, so we're going to move on in the next video, and we're going to start taking a look at a little bit higher order sorts of polynomial functions. So moving away from just quadratics for cubics and fourth order and fifth order sort of things, and we're going to take a look at the behavior of those functions.